Good morning, fifth graders. It is Monday, April 20th, 2020. Time for another science lesson. Let's first review. We're going to review the experiment, the collapsing can. That was the experiment that I did for you guys for Thursday's class. I had you go to KidBlog and I had you to predict, what do you think will happen when I turn the aluminum can over into the bowl of ice cold water? Some of you guys' prediction was correct, and some of you guys' prediction was not correct. However, the students with the incorrect predictions is pretty good. Why? I'm glad you asked. It's good because now I know that you have learned something new. But I kind of gave you guys a clue because the title of the lesson was The Collapsing Can. So some of you may have made an inference and said, well, let's see. She said, predict. She gave me a title, The Collapsing Can. So the can is probably going to collapse. So that's going to be my prediction. So I kind of gave you guys a clue on that. But the answer was the can is going to collapse or it's going to crush. Now let's answer these questions from the PowerPoint. Number 2, what crushed the can in the demonstration? Was it steam, liquid water, heat, or atmospheric pressure? The correct answer is atmospheric pressure. Number 3, in what form does water take up the most space? Is it ice, liquid, or vapor? If you said the answer is vapor, you're correct. Number 4, which of the following does water exist as? Is it liquid, steam? All answers are correct, or vapor. Your correct answer is all of them. We know that water exists as a liquid, as a steam, and in vapor. Number 5, what happens when you heat a small amount of water in a can and then submerge that can in a bowl of water? We know the can will crush into itself. And if you go back to that video where I did the experiment, you have your evidence. Number 6, what happens to the speed of particles when they go from hot to cold? The particles are going to slow down when they go from hot to cold. Remember, hot particles are going to move very, very fast, very, very fast. That's why it is hot. But as it starts to cool down, what will the particles do? The particles are also going to slow down. So therefore, when the particles go from hot to cold, they slow down. Now, what are the effects of water vapor, the form water takes on as a gas, when it undergoes changes in the atmospheric pressure? You should have said the water vapor would change states of matter. Now, fifth graders, what are your states of matter? There are 4 of them. Name them for me. Solid, liquid, gas, and what's that 4th one? We made it in class. Plasma. So now what caused the sound? Remember when I put the can in the water, I told you to observe a sound. What caused that sound? That was the evidence that we have air all around us. So the air is pushing around us. So when we put the can in that water, it proved or gave us some evidence that we have air pushing around us. Now, what caused the can to crush? Now, pay attention to the illustrations on the bottom because you guys already know everything I do, I'm going to give you an image. I need you to retain it through your image. So look at the images here on the bottom as we talk about what caused the can to crush. Now, before heating the can, it was filled with what? I had water in it. Remember, I got the water from the bowl, and it had air in it. Then the water began to change from a liquid to a gas when I put it on the stove. Now, what was the evidence that it changed from a liquid to a gas? We know it changed from a liquid to a gas because it had steam. And how did we know it had steam? The steam came out of the can. Now, when the steam came out of the can, why were we able to see that particular gas? Because we don't see gas normally. Why do we see it? You're right. The particles are bumping into each other. That's why we were able to see the steam. Now, the water vapor in the can pushed the air where? Right, It pushed the air out of the can. Now, as the water continued to boil, the molecules bounced around inside of the can, creating the force outward. So you see our molecules here. They're still in the can. They're bouncing, and you see the yellow arrows bouncing outward. But now let's think, fifth grade, what's on the outside of the can? If these molecules in air are bouncing outward, what's bouncing inward? You're absolutely right. The air molecules are bouncing inward as the air molecules in the can are bouncing outward. So now the water vapor in the can pushed the air out the can. The water boiled. The molecules bounced inside the can, creating a force. Remember, force means push or pull, pressing outward, which made the air press where? Inward. Now, as I took the can and I put it in the ice cold water, I formed an airtight seal against the surface of the water. This is the airtight seal. When I put the can on the water, it sealed it up. It said, nope, nothing's coming in and nothing's coming out. It literally sealed it up. So as I put it in the water, it formed that airtight seal against the surface. Then the water vapor condensed. Condensed means to get smaller, and it cooled back into a liquid. So therefore, it left the pressure inside the can with less pressure than the pressure was outside the can. Because the air could not get back in, what did it do? It imploded. Imploded because the air was tight. Remember, as soon as we put that can on there, it was tight. So nothing can come in, nothing can come out. So because of that reason, we had air pressure in and air pressure out. It caused the object to implode. And where did it implode? It imploded towards the center. So this is the reason that the can crushed when we put it in the ice cold water. Now let's look at some examples from the real world, because that was an experiment. In the real world, if we had a basketball and we took that basketball and we left it out in the cold all winter long, eventually, or you can use a football, a soccer ball, eventually that ball is going to start to deflate, meaning the air is going to come out of it. It's basically imploding in the center. Why is it imploding in the center? It's losing its air because we have air on the outside and we have air on the inside. So therefore, it's losing its air or its volume when the temperature drops. Now, when the temperature goes back up, you simply put more air in the ball and it will retain its shape. So that's one example of a real life example for the experiment. Another real world example is scuba divers. Now, they wear wetsuits because they have to maintain their body temperature because we know humans are wet. I hear you saying the humans are warm-blooded. We maintain our body temperature. Our body temperature does not change based on our surroundings. Our body temperature maintains the same body temperature. Now, we've talked about the ocean before. Remember that the ocean is in layers. It's not just one flat ocean. It is in layers. The further down you go, the colder it is and the darker it is. Now, you have already told me in class that you know that it's darker and colder because the sun cannot penetrate that water. The sun cannot get to the bottom of the ocean. And remember, the water has a lot of pressure. There's a lot of pressure. The further down you go, the more pressure the ocean has. The further down you go, the darker the ocean is. The further down you go, the colder the ocean is. So therefore, scuba divers, they have to wear a wetsuit that helps them to maintain their body temperature. Now, because they're humans, inside of their body, they have an organ system. Now, let's review an organ system. What would be first? Cells. What's after cells? Cells create what? Tissue. What do tissue create? Tissue system. What does tissue system create? An organ. What does an organ system create? An organ system. Now, you have liver. You don't have your liver on your dining room floor. You don't keep your stomach on top of the sink. You won't put your colon in the bathroom. No. All of your organs are working as a system. That system is working inside of your body. When scuba divers, if they go down too far in the ocean because of all the pressure of the water, and remember their bodies are maintaining that warmth, but they're going down into a cold ocean floor, their bodies can do just like that can. Their organs can crush just like that can. So this is one reason why humans are not, their bodies are not fit for them to dive too far down to the ocean's floor. So these are two real world examples of our experiment. Now, if you have any questions, you can send me a message on Edmodo, or you can email me and I'll be glad to answer any questions. Now, let's move on to today's lesson. It is mixtures. Now, fifth graders, we've already discussed mixtures, so this should be just a review. A mixture is a combination of two or more substances where there is no chemical combination or reaction. Now, we know a chemical reaction is the same as a chemical change. A chemical change is going to change whatever it is, and it will not change back. It will not become something new. We know matter cannot be what? It cannot be created or destroyed. What does it do? It becomes something new. Now, a mixture is the opposite of that. A mixture is simply a physical combination. So, mixtures are not chemical reactions or combinations, mixtures are physical. We have two types of mixtures. Now, this I did not discuss in class. This is going to be brand new, and I need you to understand it because you're going to need this for sixth grade. You have a heterogeneous mixture and you have a homogeneous mixture. Now let's take a look at what these types of mixtures are. What's the difference at the molecular level? Now, we have a heterogeneous mixture. Example of that would be chocolate milk. You see, these are not all in one straight line. They're not uniform. They're kind of all over the place. You have a homogeneous mixture. Homo means the same. These are all in the same line. They are uniform. They're not all over the place. So salt water would be an example of homogeneous mixture. So let's look at homogeneous first. It is uniform. Why do you wear a uniform? Correct. So that you all will look the same. So there's a homogeneous mixture. All of the molecules look the same. These molecules are evenly distributed. So for example, you have a salt water solution. You have iodine. You may not know what iodine is. Iodine is when you fall and let's say you get a cut or something. Mom or dad would put iodine on it. That would help it to heal. That's iodine, and it's usually red. Actually, you did see iodine now that I think about it. Those of you who got to look under the microscope, and I had the onion cell under the microscope, and I had the yeast cell under the microscope, and I had the leaf under the microscope. I put iodine on the leaf, and I put iodine on the onion, and that's how you were able to see the cells very good in the microscope. So, but iodine in the real world is used if you cut yourself. Now, you also have vinegar, whether it's dark or light. Those are homogeneous mixtures. And you have stainless steel. It's a mixture of iron, chromium, and nickel. So these are examples of a homogeneous mixture. Heterogeneous mixture, they're not evenly mixed. They're kind of scattered. They're not in a uniform. They're not just straight as a homogeneous mixture. These are easily separated. If I have salt and pepper, it would be difficult, but you could use a toothpick or something if you really want to separate salt and pepper. We have cereal. I can physically separate the cereal from each other. We have candy. These could be physically separated. We have the rocks. They could be physically separated. So that is a heterogeneous mixture. They are easily separate it physically. I can physically separate it. And it's not evenly mixed. So for a heterogeneous mixture, that means they do not appear to be uniform. Now, right here, we have a mixture of milk and soil. Now, why in the world would we want to mix soil and milk? Just to give you an illustration of what a heterogeneous mixture is. In here, you see the soil and you see the milk. They are not evenly distributed. Right here is an example of a saltwater solution. You can tell where these molecules are evenly mixed. So that's the difference between a heterogeneous and a homogeneous. Now, there are substances held together that not chemically combined, and what is that called? That is called a mixture. It holds its own identity, and these mixtures can be physically separated. So let's take a look at how to separate a mixture. There's several ways to separate it. The way you would separate it depends on what the mixture is. Every mixture will not be separated the same way. So let's take a look at some methods. Distillation. You can separate liquids by changing their boiling points. So if I have gas and kerosene and diesel oil and fuel oil, if I change the heat of those oils, actual oils or gases, I will be able to separate them because they'll be at different boiling points. Now, remember in class, we did an experiment with the water layers. As a matter of fact, there was a group of students who also did that for the STEM Fair project. Water can be layered. Remember, we use water, we use vinegar, we use alcohol, and we use corn syrup. And you guys pour those in a cup, and you saw that based on their density, that's the layer that it stopped in. So that's another way that you can separate a liquid. So remember, liquids can be separated. It doesn't just have to be a solid. You can also separate a liquid. So think about the layers that we put in our cup. You can physically separate a mixture by using your hands. Just simply pick apart the different substances. So here we have candy. If I want to separate, I could separate it by color. I could separate it by texture. I could separate it by types of candy. We have these people on a mat. It looks like they're separating by colors. They have two different substances here. I have peanuts and I have raisins. They can be separately separated by hand. Another method would be sieving or a sifter. Now, these are sievers or sifters. Where have you seen one of these in the real world? When mom and dad make spaghetti, what does you do when the spaghetti boils? After it boils, you take the spaghetti and you pour it in a sifter. A sifter is a way that you're separating your mixture of water and noodles. Also, if I took my rocks and my sand and I needed to separate them, I would put it in a sifter. What would go at the bottom? Correct. The sand would be at the bottom, and your rocks or your gravel would be inside of your sifter. So that's another way to separate a mixture. We have magnets, and we worked with magnets in class. Magnets have poles. What are the names of those poles? I'm hearing you say North Pole and South Pole. Where is a magnet the strongest? It should have been out of your mouth at the ends. Magnets are the strongest at the ends, or your poles. You have a North Pole and South Pole. Remember, your opposite poles will attract. Now, there was a group of people that would help me at the end of the day to put our trays up from the magnets. Now, they had metal pieces and then they had everything else that we had in a tray. How was it easy for them to simply put everything that was metal, which was made of iron, steel, nickel, cobalt? They was able to put that in a bag by itself very quickly. What did they do? You're right. They took a magnet, they put the magnet on a tray, and everything that was attracted to the magnet, they was able to pick it up with the magnet, put it in a bag, and everything that was left over was easy to physically separate. So that's what magnets do. They help you to separate things that's made of iron, nickel, and cobalt. And by the way, when you get to middle school, you're going to have to learn these chemical names for whatever item that you're talking about or whatever mineral that you're talking about. Now we have filtration. This is your funnel. You could take a filter paper, put it in the funnel, pour in your solid and your liquid. What would be at the bottom? You're correct. Your liquid would be at the bottom, and whatever's left behind would probably be a solid, would be left in your filter paper. Mom and Dad also uses this when they make coffee. They put the filter in the coffee pot. They put the coffee grounds in the filter. The coffee begins to percolate. When it's done, the coffee will be in the bottom of your container or your coffee pot, and in the filter, you would have your grounds. So that filtering is simply another way to separate a solid and a liquid. You can make your own filtration. You could use rocks, pebbles, and sand, fine sand, charcoal, and cotton. You put a 2-liter bottle, pour water in it, and it will actually filter your water. Evaporation or boiling. Now, we actually did this in class. We did the evaporation in class. With the boiling, you simply have a salt solution, or you can have a sugar solution, and you boil it, the water evaporate, and the solid will be left. Now, let's think about it. What did we do in class that used the evaporation method of separating a solid with the liquid? Ding, 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 ding. The cup that had the salt water. Remember, I said, can you make an egg float? And some of you said yes, and some of you said no. And then I poured the water in the cup, and the egg began to rise. So the egg was able to float in the salt water. And remember, I left it on the cart for a couple of months. And what began to happen with the water in the cup? Eventually, the water was no longer in the cup. Now, Miss Lofton did not pour the water out the cup. When we took the egg out, there would have been about month 3. We took the egg out, and there was no more water in the cup. But what happened to it, being that I didn't pour it out? You're absolutely correct. The water evaporated. So the water went out into the classroom. Maybe if the window was open, went the window, but it went out of the cup. Now, what was left in the cup? You're so smart. So that was our evidence that water used to be there, because we had salt around the rim of the cup, we had salt on the egg, we had salt all throughout the cup, but there was no more water. The water evaporated. So that's another way that you can separate a physical separation of salt and water, which is a mixture. So which method would work best? You have been given a mixture of sand, salt, and water. Which method would you use to separate that mixture? So put your thinking cap on. Would you sieve it, or use magnets, or use filtration, evaporation, or would you use a combination? Because you said method or methods. So put on your thinking caps and think about what you would do. Now, what I want you to do is I want you to go to the school's website and go to Clever. From Clever, I want you to click on Discovery Education. In your assignment, click on Assignments, and you're going to see Types of Mixtures. Today, you're going to do Engage, and you're going to do Explore. So on your Engage, there is a video. And I want you to watch this little 27-second video. You can find mixtures in your home, right in your own kitchen. Did you ever think that some of the foods you prepare and consume are mixtures? So look at that short video, read the text. Here is an image. There's another minute 48 video, and there's another image that has data with it. Then I want you to scroll down and go to your soup mix. Now it says the soup in the picture is a mixture in which ingredients are not evenly mixed and each component retain its own properties. What are the components of the soup mixture? So what I want you to do is to look at your soup mixture and put in your responses. And then how would you describe it? And then which statements are true? And then which one of those are heterogeneous? And you guys, if you don't remember which one is heterogeneous, go back to your video. And then water evaporation, what was left behind? And then record your ideas. After you have completed your first one, then I need you to click on next, and I want you to answer your explore. Okay, so when you answer your explore, you're going to scroll and you're going to simply read the text and answer any questions that it may have. And it also has a video. So this is today's assignment. If you have any questions, feel free to email me or send me a message on Edmodo. Okay? Have a good day.